Gino, what are we talking about today?
The hinge theorem.
The hinge theorem, yes. Inequalities in two triangles. We talk about the hinge theorem and the converse of the hinge theorem. I want everyone to take a look at page 191 of their student journal. It actually describes the hinge theorem. It's up here as well, so obviously you can look at that. But if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the second triangle, or the first triangle, is longer than the third side of the second. So in other words, look, if you have two triangles, and this is congruent to that, that's congruent to that, and that angle is bigger than the angle in between, than the other angle there, then this side will be bigger than that side. Okay? So this guy right here, this side has to be longer than that side because that angle is bigger than that angle. Yeah. Okay? And that's true when you're dealing with triangles where the included angle is in between congruent sides of those triangles. That's what the hinge theorem says, and the converse just says the converse of that. It talks about if you have the side length, the angle is going to be, if this side's bigger than this side, this angle is going to be bigger than that angle. All right? That's what the hinge theorem says. Now, it's something I'm guessing that most of you would be like, oh yeah, that's pretty, I get that. That's not a hard thing. Okay? It should not be a difficult lesson. Let's see how well we can apply this in some problems. I want you to take a look at page 192. I want you to work through page 192 with your groupies there. Do your bestest. Yeah, I'll actually zoom out there to see the whole thing. All right, off we go. Okay, so here we go. You guys are going to go ahead and come on up and put the answers. So this row right here gets number 1. This row number 2, 3, 4, 5, 6, 7, 8.
I volunteer to write it with my left hand.
Okay, what you guys got?
I got number 1. That's a C.
Carlo, don't do it.
Carlo, don't do it.
No. No. Let me write your guys.
Equals. Right there.
Yeah. I got this. It's the best equal sign I've ever seen. Really? Yeah. I think I'll make it into like the writing Olympics. Yeah.
Nice.
There should be a left hand.
Power of the left hand.
It's crazy.
Same.
I'm left-handed.
Because I'm actually left-handed.
I am too.
Get out of here. Not even cool, Maddie.
I'm actually left-handed, but that's not an accomplishment I must use.
Really? Look at that. Look at that, man.
Amazing.
That's just magic.
Darn it. I'm getting a pencil.
Really? Wrote the equal sign on number 3. No one did number 2 or 5. Alex, just do number 2.
Everybody has to let me write their name. Come on, don't mess up this O. If only it was like line up right.
All right, we got them all. Here we go. We didn't get them all. Who has number 9? Oh, all right. I think I had that one. That's my bad. So, number 1, they are, or BC is less than EF. Well done, because this angle is less than that angle. Number 2, we've got BC is greater than EF. Very good. Number 3, equal.
Do you like my equal sign?
Not sure. What happened to it?
It was my left-handed equal sign. I think I did pretty well for my first time.
Oh, you're using your left hand?
Yeah.
Wow. That's impressive.
Thanks. What? That doesn't even make any sense.
Okay.
We're right how I want.
Hey, number 4 is equal. Good. Number 5, less than. 6, greater than. Well done. Okay. What is number 9? Okay. Very good. Angle 1 on number 9 is bigger than angle 2 because 19 is greater than 17. Okay? All right, now, notice on all these, everyone earned half credit. No one got full credit. No one explained. So if you would have explained, we may have said something like, hey, measure of angle A is great or is less than measure of angle D. Or 35 is less than 45. Or measure of angle A is greater than measure of angle D, or 95 is greater than 20. Now, I'm pretty sure you guys, that's how you figured it out, but that's how we explain our reasoning. Here, A is equal to D. Okay? So make sure you explain. But overall, pretty darn good. Any questions? All right, let's turn the page. We love the hinge theorem, right, Gino?
Yes.
Yes. All right. There we go. Next page, number 10, number 11. I want you to write a proof. Okay? Oh, we love it. Yes. Oh, yes.
Right with your left hand, you can do anything.
Okay, ladies and gentlemen, here we go. First one.
My regular writing?
Your regular writing.
What?
Yeah. Okay. Number 1 or number 10. The statements. We have our givens. We have WY is congruent to WY by the reflexive. And then we have that angle WYX is greater than angle WYZ by the converse of the hinge theorem. Therefore, we have proven it there. We can put our little zippity-doo-dah. Okay? Guys, the other proof is about the same. All right? You're just going through, except for you're not using the converse of the hinge theorem. You're actually using the hinge theorem this time. But you have your givens. You state your reflexive property here, AC congruent to AC there, and then DC is greater than AB by the hinge theorem. Okay. Any questions?
No, I don't like the hinge theorem.
Everyone likes the hinge theorem, man.
No.
For those of you that don't like the hinge theorem, you'll be the first students I've ever heard of not liking the hinge theorem.
I hate
I
it.
just want you to know.
Being a negative Nancy.
Yeah?
That's Jacob Hubble.
Everyone give 12 and 13 a go. Due to danger reasons, I didn't hand out the rubber bands or the scissors. More concerned about the rubber bands, quite honestly. Right now. However, if we were to do that, what happens? It elasticizes. Maddie? Well done, yeah. The rubber band will get bigger, taking the side as the angle between the blades becomes bigger. Okay? As some of you are saying, it elasticizes. I'm not sure about that. Hey, on this next one, I want you to draw a picture starting from a point 10 miles north of Crow Valley. So whenever you're dealing with a picture on this, you're starting at your origin. So if I look at the picture I have up here, you start at the origin. Anytime they give you directions, you go 10 miles north of Crow Valley. We'll call Crow Valley at the origin here. Okay, a crow flies northeast for 5 miles. Another crow goes 10 miles south and travels due west 5 miles. Okay, which crow is farther?
The one that flew due west, isn't it?
Both the same distances, right? That's equal to that. That's equal to that. Which one's going to have the shorter length here? Okay, Y is shorter. It looks shorter. Why is Y shorter? What's this angle right here? 90. We're going due west. That's 90. Is this 90? It's greater than 90, right? Because we're not going due east. We're actually going northeast, which means this is an obtuse angle. Okay, therefore, this length is going to be greater than that length. So, the crow that is further away is the crow that flew north to begin with. Okay. Your assignment today is online.